We know that atoms are extremely small. The typical size is in fact 10 to the power of -8 centimeters. So, say we have an average sized orange. If we made each of its atoms equal to the orange itself, then the orange would be the size of the Earth. And that's ridiculous. And that's precisely why we talk about mass in relative terms. In chemistry, mass is given relative to the carbon-12 isotope, and this is the accepted international standard. Now, there are three key definitions you need to know. Number one, relative isotopic mass is the mass of an atom of an isotope compared to 1/12 of the mass of an atom of carbon-12. Number two, relative atomic mass is the average mass of an atom of an element compared to 1/12 of the mass of an atom of carbon-12. And thirdly, relative formula mass is the average mass of a molecule compared to 1/12 of the mass of an atom of carbon-12. So here we have a bunch of atoms. As you can see, the relative atomic masses are not whole numbers, and this is because it is an average of all the isotopes of that atom. So how do we actually calculate relative atomic mass? Say we have a bunch of chlorine, and 75% of this chlorine is composed of chlorine-37 and 25% chlorine-35. Now, of course, we can't put both of them in the periodic table. We need an average, and that's where this equation comes in. We multiply relative mass by the abundance and do this for all the isotopes, divide this by the total abundance. So in the example above, we do 37 times 75, put this in the brackets, then add 35 times 25 and divide all of this by the total abundance, which is 100, and the answer is 35.5. So it's this chlorine that we'd put in the periodic table. We can also use mass spectra to calculate relative mass. For example, this is the mass spectrum of neon. On the y-axis, we have the abundance, and the x-axis is what corresponds to isotopic mass. To get the relative mass, we need to use the same equation. So we've got a mass of 20 and an abundance of 113.5, and a mass of 21 and an abundance of 115, and finally a mass of 22 and an abundance of 125.8. Divide all this by the total abundance, which is 354.3, and the answer is 21.03. Lastly, to calculate relative formula mass, you just add up the mass of all the individual atoms in the molecule. For example, here we have CO2 and H2SO4. Carbon has a mass of 12 and there's only one carbon. Oxygen has a mass of 16 and there are two of them. Add up the masses. So CO2 has a mass of 44. Moving on to H2SO4. Hydrogen has a mass of 1 and there are two of them. Sulfur has a mass of 32.1 and there is only one of them. And finally, oxygen has a mass of 16 and there are four of them. Add up the masses. So H2SO4 has a mass of 98. Relative isotopic mass is the average mass of an atom of an isotope of an element, compared to 1/12 of the mass of an atom of carbon-12. Relative atomic mass is the weighted mean mass of an atom compared to 1/12 of the mass of an atom of carbon-12. The first thing to do is get the mass number and multiply this by the abundance. Do this for the other two isotopes. Divide by the total abundance. And the answer is 28.1. This is the same as the previous question. Get the sum of the masses multiplied by their abundance, divide by 100, and the answer is 69.8. Hydrogen has a mass of 1 and there are two of them. Sulfur is 32.1. Oxygen is 16 and there are four of them. Add up the masses and you get 98.1. With B, again, hydrogen has a mass of 1, nitrogen has a mass of 14, oxygen is 16 and there are three of them. Add them up and the answer is 63. In C, we have hydrogen and there are two of them, and one sulfur. Add up the masses and it's 34.1. D, carbon has a mass of 12 and oxygen is 16 and there are two of them. Add them up and the answer is 44. In E, calcium has a mass of 40.1, chlorine is 35.5 and there are two of them. Add them up and the answer is 110.1. And finally in F, Nitrogen has a mass of 14 and there are 2 of them. Hydrogen has a mass of 1 and there are 8 of them in total. S has a mass of 32.1 and O is 16 and there are 4 of them. And the total mass is 132.1. We have the mass and the abundance for the first isotope, so that's 75 times 35. The abundance of the second isotope must be 25, since the first one is 75%. We multiply this by the mass, which we don't know yet. Divide this by 100, and we should get 35.5. Multiply 35.5 by 100, and we get 3,550. Take away 75 times 35, and we get 925. Divide this by 25 and we get a mass of 37. Br79 has a mass of 79 and an abundance of X. Br81 has a mass of 81 and an abundance of 1 minus X. So 79X plus 81, take away 81X, divide this by 100, and we get 79.9. We can simplify this into 79.9 equals 79x plus 81, take away 81x. Move the numbers to the left and we get 79.9 minus 81 equals 79x, take away 81x. This simplifies into minus 1.1 equals minus 2x. Divide both sides by minus 2 to get x on its own. So 0.55 equals x, which is 55%. 63 times 69.17 plus 65 times 30.83, divide by 100, and the answer is 63.62. 70 times 3 plus 72 times 4 plus 73 times 1 plus 74 times 5, divide by 13, and the answer is 72.4. Multiply the relative mass by the total abundance and we get 8768. Subtract the 2 known isotopes and we get 872.9. Divide this by the remaining abundance, which is 10.2, and we get 85.6, rounded off to 86. Multiply the masses by their abundances and divide by total abundance, and the answer is 12.2. B10 has a mass of 10 and an abundance of X. B11 has a mass of 11 and an abundance of 1 minus X. So 10 times X plus 11 minus 11X divided by 100, which gives us 10.8. This gives us 10.8 equals 10x plus 11 minus 11x. Move the numbers to the left and we get 10.8 minus 11 equals 10x minus 11x, which simplifies into minus 0.2 equals minus 1x. Divide both sides by minus 1 to get x on its own. So 0.2 equals x, which is 20%.